Hello everyone, greetings for the day. I welcome you all to the second unit of AMA subject. So the title for this is Assembly Language Programming. So actually now we are going to start with the programming of a PIC18F family, that too in a assembly language. So before starting, you should know what is assembly language programming. So we know address is a pattern of zeros and ones. Address is a pattern of zeros and ones that represent a specific location in a memory or a particular I/O device. So all the programs stored in the program memory can be executed by the microcontroller's CPU, and this memory is called as main memory. So the another name for this main memory can also be the directly addressable memory. So addressing mode is the manner in which the microcontroller determines the operand. Operand is nothing but the data. Operand is nothing but the data which is to be processed. Okay. So basically addressing mode is the manner in which the microcontroller determines the data and the destination address during the execution of a instruction. So basically whatever is the part of programming in assembly language will be consisting in the format of ones and zeros. So there are some key features of PIC18F 458 family. That is, it uses a RISC architecture. It uses a RISC architecture. RISC stands for Reduced Instruction Set Computer. So RISC basically uses assembly language so that the task is broken down into the simple instructions and that can be executed depending on the clock cycle. So basically in simpler terms, RISC is basically a computer with a small, highly optimized set of instructions. It is used in portable devices due to its power efficiency. Example for this is an Apple iPod, okay, which was being designed by the researcher from IBM, okay, John Cook. So it uses a RISC architecture. Along with that, there is also a CISC architecture. So CISC architecture is nothing but a complex instruction set computer, but 18F family prefer the RISC architecture due to the features I told you. Then it uses a Harvard architecture. Okay, it uses a Harvard architecture. Already we have discussed what is exactly meant by a Harvard architecture. Then it has separate program and data memory. Okay, so these spaces are made separate along with their separate buses, and buses are nothing but the wires or the media which are used to carry the data to and from the source and the destination, where both program and data memory can be accessed simultaneously. This point is to be noted that both program and the data memory can be accessed simultaneously. It uses flash memory. The reason behind using the flash memory is to store the program memory, while the RAM contains the data memory. Okay, so so the use of flash memory is done. It makes use of several registers. We know that several registers which are used in PIC18F 458 family are the stack pointer, working register, program counter, different registers are there. Okay, so these registers are mapped as memory locations, and these registers are called as special function registers. Maximum size of program counter, we know it's 21 bit, and the data memory is accessible up to 4 kilobytes. Okay, so these are the important features as far as PIC18F 458 family is concerned. So looking into these features is not sufficient. Always we should look into the key features while selecting a microcontroller. So what are the points exactly we should look into while selecting any type of microcontroller? The first and the foremost thing is about the power efficiency. So see, there is a compromise between the processing performance and the power consumption. So a device with higher processing power will consume more energy. It is very obvious. Okay, so if microcontroller is wireless and running a rechargeable battery, then we need to sacrifice for the power. This is to be kept in mind. So we have to sacrifice for the power. Temperature tolerance is the second important feature to be kept in mind while selecting a microcontroller. Depending on the environment in which the microcontroller is going to work or is going to operate, it should always have a device which can withstand the extreme temperatures. Okay, it should be able to withstand with the extreme conditions of the temperature. So it is to be taken into mind that wherever temperature is the important issue, you have to select your microcontroller very appropriately. Third important feature may be a security. So hacking with targets IoT devices is rising, and it is a threat specially relevant to the microcontrollers only. Okay, so makers of microcontroller are using layers of security. Okay, so what are the layers of security used? They are like cryptography. Okay, and the physical security may be provided to the controllers as well. So always check for security standard while purchasing any type of microcontroller. See, basically I'll just tell you in short, IoT describes the network of physical objects or things that are embedded with the sensors, switches or other technology for the purpose of exchanging the data. So IoT consists of sensors and the devices, okay, which take to cloud through connectivity. So once data goes onto the cloud, okay, then the process it is then decides the performance action. Okay, so these things are to be noticed while selecting the microcontroller. Then hardware architecture also plays an important role while selecting a microcontroller. A microcontroller's packaging which directly is going to influence its size and performance. So whenever you see a controller, its hardware architecture should be in such a way that it should not affect or it should not influence the performance. Okay, so most widely preferred is a DIP package. DIP stands for dual inline package. Okay, then is a processing power. So how much processing power do you require for the task, or whether a single core processor can fulfill our requirement, or do you need a multi-core processor? All these questions should arise in your mind when you think about purchasing a microcontroller and you think about a processing power of it. Then is the important issue about memory. The amount of memory you need will be depending upon the programs you are going to run on that particular controller. Then you should have a hardware interface. So the nature of your task will dictate the need of hardware interface. As hardware interface is important, software interface or software architecture is also of that importance only. Okay, so what is OS? That is operating system. OS is nothing but the interface between the computer user and the computer hardware. Okay, OS is what? It is just acting as an interface in between whom? The computer user and the computer hardware. Okay, so some microcontrollers are operable on multiple OS. Okay, so OS performs all the basic tasks. What type of task do the OS perform? Generally you know that like file management, memory management, process management and IO handling. Okay, so all these things are to be kept in mind while selecting any type of controller. Thank you.